Example here of finding a derivative using the limit definition. So I've picked a simple rational function 1 over x, and we're going to talk about finding the derivative of g evaluated at 3. So what I'm talking about is what is the tangent slope of the function g of x at x is equal to 3. That's g prime of 3. So let's talk about it for a moment. Okay. So first of all, we're going to talk about plugging it into the limit definition. This is the limit as h approaches 0 of f of x plus h. So everywhere I find an x, I put in the value of x plus h instead, minus f of x, which is the function 1 over x, all over x plus h minus x. And again, this is secant slope that we're talking here, but we're going to let h approach 0. This is the change in the y's over the change in the x's. So in this particular case with rational functions, we have to subtract two fractions, so we got to find common denominators. We multiply by 1 on this side and by 1 on this side, but we do it in a manner that will give us common denominators. Okay, so this cleans up to look like this: x over x times quantity x plus h minus x plus h over the quantity x times x plus h. And we can't just forget to distribute that negative again. So this is x minus h. So x minus x cancels out, and all we're left with up top is the negative h. The denominator is, of course, the same denominator, x times the quantity of x plus h. And then what did I do over here? Well, this all chunk up here was division by division by h. So that's the same thing as multiplying by its reciprocal. So instead of dividing by h, I multiplied by 1 over h. You'll see here now that the h's cancel, so that gets rid of my problem where h approaches 0. So I'm left with the function of negative 1 over x times x plus h. As I let h go to 0, this is basically negative 1 over x times x, which is negative 1 over x squared, which is the function g prime of x. Okay, so we've found our first derivative. Yay. Well, maybe the second one, but yay. And now if I want to evaluate that function at 3, which again, we're finding the slope of the line tangent to g of x at x is equal to 3. The tangent slope, if I plug 3 into the derivative, is negative 1 over 3 squared. Again, here's my g prime of x. So it's negative 1/9, and this is the tangent slope of gx at x is equal to 3. It's not the point, it's the tangent slope. The point gx would be what? Well, gx is 1 over x, so the point would be 3 comma 1/3. The slope would be negative 1/9, and we could put that in point slope form and find an equation of a line if we wanted. Good enough for today.